Assalamu alaikum warahmatullahi ta'ala wabarakatuh. In this video, I will try to explain the integration and how to use the technique of integration by parts. So let's start with an example. We want to calculate the integral between 0 and 2 of x squared plus 2x minus 1 dx. First of all, this is the notation of integral. So the notation is the symbol right here from 0, so between two numbers 0 and 2 of the function that we need to integrate should be continuous in your course. To find this integral, all we need to do is to find the primitive function of fx, of x squared plus 2x minus 1. This is also a notation. We put here the primitive function, primitive function. This is a notation to facilitate the calculation, because we know that the integral between AB fx dx is fb minus fa, such that capital F is the primitive function of f. So we put the primitive function inside those and calculate the difference between fb and fa. So what is the primitive function of x squared? We know that the primitive function of x squared is x cubed over 3. The primitive function of xn is 1 over n plus 1 x n plus 1. So what is the primitive function of x to the power 7 is 1 over 8 x to the power 8. The primitive function of x squared, if we do the same thing, the primitive function of x squared as x cubed, the primitive function of x, because we have here 2x, is x squared over 2. So the primitive function of 2x is 2 times x squared over 2. If we simplify by 2, we'll find x squared. So the primitive function of 2x is x squared. The primitive function of 1 is x, because the derivative of x is equals to 1 between 0 and 2. So all we need to do now is to calculate the difference between those two numbers. First of all, we need to replace x by 2 in all this function. So it's 2 cubed over 3 plus, here, x squared plus 2 squared minus 2, all of that minus 0 cubed over 3 plus 0 squared minus 0. This is equals to 0. So if we calculate this, we will find 8 over 3 plus 4 minus 2. It's 8 over 3 plus 2. It's exactly 14 over 3. Let's do another example. Let's calculate the integral between 0 and 1 of exponential x plus 1 dx. Same thing. The primitive function of exponential x is exponential x, because the derivative of exponential x is exactly exponential x. The primitive function of 1 is x between 0 and 1. Replaced by 1, exponential 1 plus 1, then by 0, exponential 0 plus 0. This is e, the number e, plus 1 minus 1, which is exactly e. Sometimes it's hard to see the primitive function directly. For example, 2x over 1 plus x squared. So you need to do more exercises in order to see those formulas. We know that u prime over u, the derivative over the function, its primitive is exactly ln absolute value of u. So if we can write this function in the form of u prime over u, we can find easily the primitive function. Here you can find the absolute value because we need to make sure that ln, what's inside ln is strictly positive. So let's try to write this in this form. Integral between 0 and 1. If we take the denominator and derivate the denominator, 1 plus x squared is exactly 2x. So we can write this in the form of 1 plus x squared prime over 1 plus x squared dx, which is exactly the primitive of this function is ln 1 plus x squared without absolute value here because 1 plus x squared is strictly positive equals to ln. Now we will replace by 1 square is 1 plus 1 is 2. If we replace by 0, 1 plus 0 is 1, ln 1 is 0, so the integral is ln 2. This is the first technique to calculate the integral. Let's see another problem. Integration by parts. Let's take an example to understand how to calculate this integral. 0, 1 x exponential x dx. We don't have any formula to find the primitive function of x exponential x. So what we need to do is to find the technique so we can remove this x from exponential x. So let's try to come up with this technique. What is the derivative of u times v? The derivative is u prime times v plus v prime times u. So u prime times v is equals to u times v prime, all prime, minus v prime times u, which lead us to the integral of u prime times v is exactly the integral of u times v all prime minus the integral of v prime times u. We know that the primitive of u times v prime is exactly u times v minus the integral of v prime times u. As you can see here, the derivative switch place from u to v here. So if we want to eliminate x, we can do the same technique. All we need to do is to put ux equals to x and v prime x equals to exponential x. And switch that to u prime in place of u. So the prime of x is 1 and the primitive of v prime is v is exactly the primitive of exponential x. The primitive of exponential is exponential. So if we apply this technique, we can find that the integral between 0 1 x exponential x dx is equals to the primitives, multiplication of the primitives, so x exponential x between 0 and 1 minus the integral of, so it's 1 times exponential x dx between 0 and 1. This is exactly x exponential x between 0 and 1. What is the primitive function of exponential x? Is exponential x between 0 and 1. And this is exactly x exponential x minus exponential x between 0 and 1, which is, if replaced by 1, it's e minus e. If replaced by 0, this is 0, this is minus, so it's become plus exponential of 0 is 1. So it's 1. Let's do another example of this integration by part. Integral between 0, 1, or let's take 0 pi over 3 x cosine x dx. Using the integration by parts, we put ux equals x and v prime x equals cosine x, which lead us to, we did the same thing as previous example. We need to calculate u prime x, which is 1, and vx, the primitive of v prime, so the primitive of cosine is sine x. So the integral between 0 pi over 3 x cosine x dx equals to the primitives x sine x, the multiplication of the primitives between 0 pi over 3 minus the integral of the result. This is the result. So the integral of 1 times sine x is sine x between 0 pi over 3 dx, sine x. Now we can replace by pi over 3. We need to replace x by pi over 3. Pi over 3 sine pi over 3 minus, if we replace by 0, we'll find 0. And we need to calculate the primitive of sine x. Sine x, its primitive is minus cosine x. Minus cosine x. So minus with minus, it's become plus cosine x between 0 pi over 3. Pi over 3, the sine of pi over 3 is root 3 over 2. Here we need to replace by cosine of pi over 3 minus cosine 0. Pi over 3 root 3, let's do some simplification. Pi root 3 over 6 plus cosine of pi over 3 is 1 over 2. Cosine of 0 is 1. Which leads us to pi root 3 over 6 minus 1 over 2. So I let you with an exercise. Please practice. Practice makes you perfect. So calculate those integrals. Integral between 0, 1 of x sine x dx. Second integral, the integral between 0, 1, let's say x plus 1 exponential x dx. And finally, here you need to use integration by part 2 times. Okay? 2 times integration by parts.